your optimization. That is a important aspect to review the system design architecture and analysis. Another two small things are your programming and networking administration. Programming, you're not going to be a developer, but it is good to know if you already know Java or a .NET or Python. It is an added advantage because you're going to talk to a developer and then tell that there is a problem in your code. So when you are already know a little bit of programming, it helps you in talking a little more confidently to the developer. Okay? And same way for networking administration, you cannot expect the other person to come and install you tools, softwares, deploy, configure, restart. All these things, it is expected from you to do it on yourself. So you should get hands-on on Linux, installing tools, deploying your application in the server. All these things you should get an hands-on. Okay, so all this put together is what it will make a good performance engineer. Okay. So through this course, what we are trying to do is testing is already taken care. You know about testing. System analysis is what we are going to cover from the engineering perspective. All these things, whatever I have mentioned, I'll go through the course content little shortly. What we are going to cover in depth anyway. Okay, there's more of a introduction before we go to the content. For you to understand what all things are required from a performance engineer. So analysis is going to be everything, and programming point of view, we will have a couple of sessions at the beginning itself to make you a little bit comfortable on the terminologies. We don't want you to do a black box testing or a black box engineering. You should know our typical program is created, our typically multiple classes are created. What is class, what is object, what is method, our deployment is done, our jar is created, our var is created, our multiple classes are called internally, how we are going to make a database connection, how do we are going to make a HTTP connection from a program. So all these aspects, we wanted to have a kind of ice-breaking session so that you don't feel that, okay, I'm going to go and talk to a developer, and even when I'm going to say there's a response time problem, we are questioned many times, right? They will question us saying your data is a problem, your scripting might have a problem. They will not accept there is a problem with the application. It is going to be very difficult to convince them. Now, if you're going to go and say your code is having a problem, your method is having a problem, your object is having a problem, if you just go and talk as a black box without much confidence, they're definitely not going to accept the issue. Okay, so for us to get that extra confidence, go and talk to a developer pinpointing a problem, you should know how our application is going to look like, how a method is going to look like, how a class is going to look like, right? So you get, when you go and talk to them, you get that extra level of confidence to go and talk to a developer. That is what we will be doing it in the initial part of your course, right? So from a course perspective, from a topic perspective, that is something we will start with the Java basics. Okay, what I was saying, we'll go and create few programs in Eclipse, compile it, run it. That is something for you to get that kickstart your journey. Okay, so initially at the start of the course, we will go through the Java basics, and then the JVM basics, which are both are required for you to make sure that you're not doing your engineering as a black box. Okay, and also all these topics what I'm going to talk about, right? It's going to be practical as well. In the right hand side, the last column, right? I've given all the list of tools that we'll be using it along with the topics. Okay, so all these tools are going to be either open source or commercial, but even if it is commercial, you will be able to install it in your machine or set it up a cloud account. For example, AppDynamics, right? Or a JProfiler. Both are commercial tools, but you will be able to install it or connect to AppDynamics cloud with a trial account, and you can use it for at least 2 or 3 months for your training practice. Okay, so whatever I'm teaching, 100% you would be able to do it on your own, install it in your machine, and then practice after the sessions are over in the weekend or in the evening time, you would be able to go and practice it by installing it. All we are expecting you to do is have this basic setup in your laptop. Yeah, you need a laptop, you need a Java, you need few softwares like Eclipse, Tomcat, and then tools like JProfiler, JVisualVM, JConsole. All these tools, um, all these are all very basic tools um, to start with, right? This is what we need. Okay, and as we move forward for every topics, I'll provide you the software which is has to be installed and from where to install. We will have the Google Drive from where you can download all these softwares, or I'll provide you a link from where you can download it. Either way, okay. So everything will be driven through this Google Drive. All the artifacts, all the war file or code that we use it, the scripts, Jmeter scripts that we use it, on all the document that we create from a response time analysis, memory analysis, your thread analysis, all that we do uploaded into the drive, which you just give me 1 second. Sorry, yeah. So everything will be uploaded to the this drive, which you will have an access, right? So all the softwares what I'm talking about will also be available in this drive, and if you go to the softwares and links, there you will get links from where you can download the software as well. Okay, once you register, you will get access to the drive through which you will be able to download and all the artifacts or the softwares for your practice. Okay, and the way we are going to learn, we are going to build, say I will have an Eclipse in which I will have a sample application code. You may not need to have the code with you or Eclipse. This is optional, but will go and do the some of the changes in the I would have done some changes in the code through which I will be deploying the war file, and the war file you will get it. Okay, war file, it will be there in the drive. So for example, if I wanted to analyze the response time problem, there will be a response time analysis folder. In that you will get a war file with issues. Okay, that you need to go and deploy it in your Tomcat. Okay, for example, I'll show you all these things in detail as we start the courses. Anyway, I'm just telling how this is going to be done, right? So I'll be sending you the war file. You will be having a Tomcat in your mission, and you will be able to go and deploy this war file in your mission, elibrary.war file. And then I will just start this Tomcat to show you the sample application as well. Okay, the sample application has a lot of functionalities. Front end, you have a Java code, and it is also having MySQL DB. Okay, so all our training will be based on this Java application, where for response time analysis, memory analysis, thread dumps, heap dumps, GC analysis, everything will be based on this application, where there will be already there will be some issues that are available in the application, and we will be trying to use all these AppDynamics or JProfiler or JConsole, JVisualVM tools to troubleshoot this problem and then find out all the response time issue or memory issue or a thread issue. Okay, so yeah, pretty much it is going to be practical, plus the concepts has to be teached theoretically. So it is going to be combination of both theoretical and practical. Okay, let me open the application. It is going to be a sample application, a Java application, which we are going to use it. Okay, and then I'll log into this. Okay, so it is going to have a couple of functionalities once you log in. You can log in as an admin login, or you can log in as a librarian login. Library login will have 7 to 8 functionalities. Your admin login have 3 to 4 functionalities. Right? Yeah. So this is a setup you will also need to have it in your mission. Minimum is your Java, your Tomcat, and this sample application, and the tools as we move along. Okay, so you have this view librarian, and where it will list down all the librarians in the app, and then you can go and add a librarian. New library you can add it, and then you can do a logout, and then using this librarian, right, with this user ID and password, you will be able to log in as a librarian login as well, and there you will have a other list of 5-6 functionalities. Okay, so that is how our courses are going to be conducted. Okay, it is going to completely, we will build it, we'll deploy it, we will test it, we'll identify the performance problem, and then we will diagnose what is a problem with the code, and then we will go and fix it. Again, we will go and test it. That's how it is going to be for most of your um, sessions. Okay, so coming back to these sessions, as I said, we will start with the Java basics and JVM basics, and from there, what we are going to assume is, we are going to assume that you are going to be a performance engineer who are going to involve early in the life cycle. Okay, that is early in the life cycle is going to be a important thing that you need to understand. As a performance tester, right, you will be involved only in the testing phase, or maybe a bit before the testing phase, where you go and create a script. But as a performance engineer, your relevancy in your project is going to be more. You're going to get involved much early in the life cycle. As the development is started, as they start to develop the code, right, you will get involved to do the early performance engineering. And even when the app goes to production, and analyzing the performance in production, analyzing your non-functional aspects, what that is happening in your production, synthetic monitoring, real user monitoring analysis, right? So you should shift left and shift right. Either way, you as a performance engineer will get involved. That's a huge advantage, right? So when you get into any job, if your relevancy is going to be more in the life cycle, more aspect you're going to work and deliver when compared to the performance tester. Okay, so what you're going to assume is, you're going to assume that you're going to involve in a uh, product where your development has started, and you're going to start doing the early performance engineering as the code is getting delivered. Okay, so we will be looking into the response time analysis, response time issue, how to optimize the response time, analyzing the response time problem with the tools like JProfiler. Okay, both from the server side and also from the client side. Right, client side metrics, what are the web vitals, how to analyze those web vitals using developer tool, how to provide the optimization from the client side and the server side. So that is what we will cover it from the response time perspective at the shift left. Okay, and then we will move along to the, for the same application, same pages, same functionality. We will also look into the memory aspect. Okay, so when it comes to optimization, there are three aspects: your response time, which is related to the CPU, your memory, and then your thread. All these things are important from a performance of your server or capacity of the server. And as a performance engineer, that is what you're going to analyze early in the life cycle. Okay, your response time analysis, your memory analysis, and as part of memory analysis, we are going to deep dive into many aspects: your Java heap, Java stack, what is the difference, what kind of analysis you have to do it for heap and stack, what are the tuning flags, configuration flags from heap and stack, and we will go and do the memory pattern analysis, memory leak analysis, identify leaks in objects, and more from the endurance test, what will we looking for, why do we run the endurance test, and during endurance test, what kind of monitoring you have to do it, what is the memory pattern you will look for, and then based on that, how do you take heap dump, and in what frequency you will take heap dump, when to take heap dump, what to take, how to take the heap dump, and how to analyze the heap dump, right? All these things we'll be looking into it in detail. And as we move along, you will also look into the GC from a memory perspective. What is the concept behind GC? What are various activity that happens in GC? Compacting, deletion, marking. What are the various collectors? what is GC log and how to look into the GC logs, right? And what are the various component inside your GC, like the young generation, old generation, what are the various tuning flags associated with the GCs. All these things we will be looking into it in detail. So memory itself, it will be more than a week-long session that will happen for your Java heap, stack, leak, dump, and GC analysis. Okay, and then from there we will move on to the threads. Thread, again, as I said, is the third component, important component, which will decide your overall performance. So we'll look into what is Java threads, what are the thread contentions, what are the problems that will come with the thread, how to configure the threads, and then how to diagnose a thread problem. When you run a load test, how do you know it is a thread problem or a memory problem, or a response time problem? What are symptoms before which you decide when to take the thread dumps, how to take the thread dumps, what is the thumb rule for taking thread dumps, how to analyze it? All these things we'll be looking into it in detail, right? So once you analyze all these, your memory, your response time, your thread, then when it comes to load testing or any stress testing or endurance testing, you should have a strong monitoring strategy, right? Like a performance strategy, you should also have a um, uh, monitoring strategy depending upon your architecture. So we'll talk about, for any architecture, how do you look into the architecture, how do you create a monitoring strategy, because it is very important. When you do a test, you should monitor. If you are not monitoring any of the component, you will not know what is happening. So how to create a monitoring strategy? And from a monitoring perspective, we'll look into two things. One is your commercial tool, AppDynamics, and second is an open source tool called Telegraph, Inflex, and Grafana. Right? One is more from the infrastructure monitoring, your Linux or Windows server, right? Server level monitoring. How can you automate, unless the way we used to use the your Perfmon or VMstat, top, IOstat kind of tools in Linux, right? Those are all old days. Now it is getting automated using Grafana and Telegraph. So we'll go and try to understand. We'll go and manually ourselves install these tools, configure it, and then monitor it using the Telegraph and Grafana. And same way for AppDynamics third-party calls analysis, creating the alerts. So all root cause analysis and deep dive diagnostics as well, we will do it using the AppDynamics. Okay, and all these things from application perspective, we'll be looking at it in detail. And from a database perspective as well, we will go and understand the concepts of Oracle. Oracle being a very common in any enterprise architecture. We try to understand how Oracle works, what is the memory architecture, what is the process architecture, what are the various important performance aspects like parsing, efficiency, your cache hit ratio, what to look for in an AWR report, how to take snapshots, how to take AWR reports, what to look into AWR report from an application engineering perspective, right? We are not going to be a DBA. We're not going to be database performance engineer. Right? They are something very niche jobs, niche area where application performance engineer will not be allowed to do the DB tuning or your database configurations. That will be taken care by your DBS only. But as an application performance engineer, what is that scope within ourselves from a database perspective? From that angle, we will go and understand the concepts of parsing, cache hit ratio, and then to look into the AWR reports. Okay, and at the last, we'll go and look into the non-functional requirements and engineering strategy. Once you learned all these topics, right, you would be able to now go and draft your engineering strategy by yourself. Okay, earlier we used to have this engineering strategy at the beginning, but what we felt is, once you learn all these things, then you will know how to write your engineering strategy as well. So we will go and look into engineering strategy at the end, and we'll also understand how non-functional requirements are gathered, what are those NFRs, how to gather these NFRs and analyze these things. We will be looking into it as well at the end. And additionally, so all these things are all engineering topics which we are going to learn through this course. And additionally, depending upon the expectation in the current market, some of these are buzz today. Some of these are, people always talk about it, whether they use it or not. So as a performance engineer, in addition to these things, to crack the interviews or to get into some of this discussion, we will introduce you to the DevOps. continuous performance testing. What is a continuous performance testing? What are the myths around it? What are the best practices we do it practically real time? Those things will cover it along with your Jenkins and Jmeter integration. Okay, and synthetic monitoring as well from a SRE or your shift right that happens in production. We'll try to use Dynatrace to understand the concept of synthetic monitoring, how to create the synthetic scripts, how to configure it, what are all things to look into it. Okay, that is also we'll look into it. And then more from the cloud, where everywhere